Okay. Okay, so let me start. Okay, so my name is Nilmoni Karak. I am the official PMRF and NPTEL TA for the course Fourier Analysis and its application. And so, yeah, I'm a research scholar from IIT Kharagpur. And today we will discuss some problem which will help you to solve assignment 1 and assignment 2. Okay. Okay. Uh, I think there is a problem related to Bernoulli polynomial, right? Maybe in assignment 2. So Pnx is the nth Bernoulli polynomial, right? Bernoulli polynomial. Then you're supposed to find the value of B3 half. Okay. So the question is not same with assignment 2. Okay. So now I think you have seen the definition of Bernoulli polynomial, right? So basically, yeah, this is defined inductively. Okay, right? Bnx. So basically, we know the value of b naught x, that is 1, and bn dash, this is derivative, equals to n time bn minus 1 of x for all n greater equals to 1, and also it holds 0 to 1 bnx integral 0 to 1 bnx dx equals to 0 for all n. This is true, right? Okay. So you have to find what is B3 x. What is B3 x? Actually, yeah, sir has mentioned. Sorry, sir has mentioned some few Bernoulli polynomial, but he did not calculate. Okay, so you can calculate using this. Okay, see. Okay, okay, no. So yeah, what is B1 dash x? This is equals to 1 times B naught x, and this is nothing but 1. Okay, so from here, so this is a differential equation, right? B1 dash x equals to 1. So what is B1 x then? Basically x plus c, right? You integrate with respect to x both sides and you will get this. Okay, and c is your constant. And now you have one condition. Okay, 0 to 1 b1 x dx. Okay, okay. So b1 x equals to your uh, 0, right? So from here you just integrate 0 to 1. Here b1x equals to your x plus c dx equals to 0. Then your x square by 2 plus cx 0 to 1 equals to 0, and from here c plus half equals to 0, and c is nothing but your minus half. Okay, so you are getting basically b1x equals to x minus half. Now similarly you can calculate b2x. Okay, so b2, what is b2? b2 dash x equals to n times, so here n is 2, b1x. Okay, and what is b1x? You got just b1x is x minus half. Okay, and also so this is differential equation, right? So you integrate both sides. b2x will be your 2 times x square by 2 minus, so this 2 times half is 1 and this minus 1, so right. And here one constant will be there, so, and finally p2x is x square minus x plus c. Now similarly, so you integrate 0 to 1 b2x dx, that is 0, and put the value of b2x x square minus x plus c dx equals to 0, and 1 by 3 minus 1, sorry, 1 by 2 plus c equals to 0. So this is basically your half, c equals to half minus 1 by 3, so this is nothing but 1 by 6. And finally you are getting b2x is x square minus x plus 1 by 6. Okay, now I need to calculate b3 half. Okay, b3 half. So similarly b3 dash x is your 3 times b2x, and this is 3x square minus x plus 1 by 6, and b3x is your x cube uh, minus 3 by 2 x square plus x by 2. Okay, and plus c also there, plus c. And now to calculate c, you integrate 0 to 1 b3x dx equals to 0, and, put this here, and you will get 1 by 4 minus 1 by 2 plus 1 by 4 uh, plus c equals to 0. So you can see c is your 0. Okay, so finally p3x equals to x cube minus 3 by 2 x square plus x by 2. And what is b3 half then? Cube minus 3 by 2 half square plus half square, right? And half square you take common, then half minus 3 by 2 plus 1. So this is 0, right? So that's why this should be 0. Yeah, hence b3 half is 0. So you can check mostly like bn 2n plus 1 x equals to 0 for all n. Okay, but just I wanted to calculate it. That's why like I did this. And okay, is it clear? Hi, Muhammad and Ognivo. Is it clear? So you can open your mic and answer. Hello, am I audible? Hello, hello. Okay, so okay, I hope it is clear. And next problem is about your Bessel function of the first kind. Okay, so the value of a such that a 19.3 plus a 17.4 equals to 8 times a 18 of 3 4, sorry, not 4, sorry, 3, and this is also 3. Okay, hi Ogniv, am I audible? Hello. Hello. Okay, so recall the Bessel's function of the first kind of order k is denoted by jkz and defined as jkz equals to n equals to 0 to infinity minus 1 to the power n factorial, n plus k factorial, and z2 and k plus 2n. And jkz holds the property j jk minus 1z equals to 2k by z jkz. Okay, uh, this is easy to prove. Okay, like you start with like left side, left hand side. So jk plus 1z and jk minus 1z, and just arrange the terms. So you will get this. Okay, I'm not going to prove it. And yeah, so uh, put k equals to 18. Then j 19, and yeah, z equals to your 3, right? 3. Yeah. So j 19 3 plus j 17 3 equals to your 2 times 18 divided by 3, and j 18 3. So so you have to like find this a such that this holds. Okay, so here a is your this is your basically 12, 12 times. Okay, so a is your 12. Is it clear? Hello. Okay. Okay, just 1 minute. Um, Next problem is question 3. Find the value of the following limits. Limit tau tending to infinity, cos inverse mu tau, and limit tau tending to 0 plus, sorry, cot inverse mu tau. Okay, so what is nu naught? So this is called actually theta function, Jacobi theta function. Okay, this is called Jacobi theta function. The function nu tau basically defined by this infinite sum and minus pi n square tau. It holds for real part of tau is positive. Okay, and is called the theta function of Jacobi, and also this holds nu naught t equals to 1 over tau. This functional equation. So basically, this is a functional equation. If you put some tau, so you will get the value of tau if you know this the functional value of 1 by tau. Okay. Mm, so okay. So this special function uh, holds basically this holds the following when nu naught tau equals to 1 plus 2 exponential minus pi times tau times big O 1. Okay, as tau tending to infinity. So what is the definition of big O wow? So as your tau tending to infinity, f of tau is big O g of tau. Okay, so for basically okay, as t tending to infinity, if there exists constant such that uh, mod of f tau greater equals to c time g tau. This g tau is always positive. Okay, g tau and for all tau greater equals to, so if you if you like yeah, take complex number domains, if you take complex number domains, in that case, so some real part of tau greater equals to some number. Okay, not like that, so you can simply consider here tau greater equals to tau naught. So tau naught is your any real number. Okay, so how to like how do you get that like this new tau equals to this? So simply you will get from here. Okay, this is nothing but a geometric series. So new tau equals to what? This minus infinity to infinity minus pi what? Pi n square tau. So this is nothing but at n equals to 0, this is 1. So 1 plus 2 times n equals to 1 to infinity. Okay, yeah, exponential minus pi n square tau. Now 1 plus, sorry, this 2. So this is a basically geometric series, right? So first term is your minus pi n square tau and divided by 1. Okay, so this 1 2 square 1 minus pi tau. Sorry, this is also minus pi tau. Okay, so basically this is 1 square 2 square, not like this. So n square, basically this is, yeah, no problem. What is this? Basically e to the power minus pi tau plus e to the power minus pi 4 tau, and write 4 pi tau plus e to the power minus 9 pi tau plus so on. 1 plus 2 times to the power minus pi tau. Oh, sorry. Okay. So, like your minus 3 pi tau plus e to the power minus 8 pi tau. So you can see like this is itself big O one. Okay, so constant which is bounded by one, and this is also bounded by one. This is also bounded by one. So that's how you will get minus pi tau times big O one. Okay, so as of course as tau tending to infinity only, this is bounded. Tau tending to infinity, this is basically goes to zero, right? To the power minus infinity basically goes to zero. So that's why this is true. And yeah, so finally you are getting tau equals to 1 plus 2 exponential minus pi tau times big O 1 as tau tending to infinity. And what about next? Yeah, next is, so this is like star, and also it holds your nu tau equals to this functional equation uh, as tau tending to, so no, this holds only uh, for real part of tau greater than 0. And you see, uh, yeah, so we are now trying to see uh, as t tending to, what is the behavior of this t tending to 0 plus, what is the behavior of nu not t. So yeah, so this is basically uh, this from here. So if you know, you already know the behavior as tau tending to infinity. So here if you put tau tending to infinity, this will like you will get yeah, sorry, if you put like if you take as t tending to 0 plus, so you need like you need to know the behavior of nu naught t as t tending to infinity. This you already know. Okay, so tau equals to 1 by root 2 root tau and 1 plus 2 times exponential minus pi tau big O 1. Now see, this is 1 by root tau, and this is as tau tending to 0, as tau tending to 0, this is 1. So you can write here instead of this little o 1, right? Okay, okay. So this is little o, sorry, one thing. Okay, so this is basically 1 by root tau 2 times exponential minus pi tau big O 1. So calculate this limit, uh, 1 by this limit. So basically you know the definition of little o also, right? Little o So if equals to, sorry, little g, if limit tau tending to 0 plus f by z. So basically both are function of tau is 0. So I'm claiming actually 1 by root tau is little o 1, a plus little o 1. So to show this is little o 1, what you should, so this big O one is not problematic. So this is basically just constant term. Okay. So like 2. Okay. So limit tau tending to 0 plus 1 divided by 2 root tau exponential minus pi tau and big O 1. So this is nothing but limit tau tending to 0 plus this root tau will be in numerator and 2 times big O 1 exponential minus pi tau. So tau tending to 0. So basically this is 0. And so that's why from little o definition this is little o 1. Okay. And now finally what we got, um, nu naught t is basically 1 by root tau plus little o 1 as tau tending to 0 plus. Okay. And so little o 1 means you can also say big O 1. Okay. And nu naught tau is your 1 plus exponential 2 times exponential minus tau pi times tau into big O 1 as tau tending to infinity. Okay. Now my question is like how to find this inverse. Okay. So t tending to infinity and tau tending to infinity and tau tending to 0 plus. So you have this result. Okay. So limit tau tending to infinity. What? Tau tending to infinity. Uh, cos inverse nu naught t. Cos inverse nu naught tau. Okay. So as t tending to infinity, so this is not problematic because this is continuous, so you can take inside this limit. Okay, so this is cos inverse limit inverse tau. This is cos inverse limit. Okay, so this is basically this. Okay, and so 1 plus the limit 2 times the limit tau tending to infinity exponential minus tau big O 1. So this is nothing but your 0 and this is cos inverse 1 and this is 0. Okay, and okay, and what is the next limit to find? Limit tau tending to 0 plus cot inverse uh, nu naught tau. Okay, so when tau tending to 0 plus, so you have this formula, right? So see, as tau tending to 0, this little o means basically you will have 0 or this. So this is similarly cot inverse limit tau tending to 0 plus this 1 by root tau. Uh, okay, am I right or not? And This is cot inverse infinity. This is basically your zero. No problem. Okay, so did you get it? Hi Ognibo, did you follow this? You can open your mic. Hello. Okay. Now question 4. Okay. Find the value of 1 by root pi integration r exponential minus 8 square dt. Okay, so in your question like is like 4. Okay, no problem. How to solve it? Consider I equals to 1 by root pi minus infinity to infinity exponential minus 8 square dt. Okay, now what is your I square? What is your I square? So you are multiplying the same integral, okay, with I, and this will be minus infinity to infinity exponential minus a x square and minus infinity. So you have dx and infinity to infinity exponential minus a y square dy. So what is this? Just pi minus infinity to infinity minus infinity to infinity exponential minus a x square plus y square dx dy. Now simple, you know how to solve it. So just put x equals to r cos theta, y equals to r sin theta. Then the limit will be, so theta is whole, right? So you are considering the circle, infinite circle basically. Okay, so the theta lies between your 0 to 2 pi and r, so you are taking r from 0 to infinity, right? So that whole region will be covered. Okay, so 0 less than r less than infinity. So now, and also one thing, what should be the Jacobian? So this dx dy will be replaced by dr d theta, right? But we multiply with one Jacobian. So Jacobian, you know how to calculate. Basically, Jacobian is this your r cos theta, r sin theta, and what is the derivative of this? Minus r sin theta, r cos theta, and this is nothing but wait a minute, I wrong. Okay, sorry. So basically, Do you know how to calculate Jacobian? Hi Ognivo. Yeah, date of the matrix I will know, but from here for this transformation what? You know? Yeah, I was wrong actually. So this is del x by del r, del y by del r, del x by del theta, del y by del theta. Right? So this is your del x by del cos theta, del y by del r sin theta, and del x by del theta is your minus r sin theta, and del y by del theta is r cos theta. So this is nothing but your r cos square theta plus sin square theta. This is r, this is positive. Okay. So basically this integral 1 by pi 0 to 2 pi theta and r is your 0 to infinity exponential minus a r square r dr d theta. So this theta integral is independent, so you can like 1 by pi times 2 pi, the integral will be 2 pi and 0 to infinity, and you can take like 1 by root a times 2 times root a. Okay, why? Because you have to adjust this to calculate this d of root a r square. Yeah, right. Simple calculation. So pi cancel, 2 cancel, 1 by root a, and okay. So this is like a r square. No, am I wrong or right? Oh, no problem. Sorry. So you don't have to take this a. Okay, no problem. So divided by minus a and 0 to infinity. So sorry. And here the calculation is right. 1 by pi times 2 pi, and half will come because of this d of r square. Okay. Yeah. Okay. So for 0, this is 0. So this is 1 by a basically. And finally, I is your 1 by root a. Okay. I is your 1 by root a. 1 by root pi r t minus it square dt is your root a. Okay. Is it clear, right, Ognibo? Okay. So the next question is also easy. Okay. So question, I think question number 5. Yeah. The constant term in the Fourier series expansion of pi square minus x square to the power 4 by 5 is your half pi 8 by 5 bpq. Then find p plus q. Okay, the question is very simple. Just you have to like find the integral, right? Constant term, so this basically pi square minus x square is suitable function to find Fourier series expansion. So this a naught plus this sum n equals to 1 to infinity n cos nx plus pn sin nx. Okay, and so you have to find this constant only. So the constant term, this you know how to find it. The constant term is basically 1 by this integral. You have to like you can calculate by this integral minus pi to pi minus pi square x square. So basically fx dx integration 1 by 2 pi integration minus pi to pi fx dx. Okay, but how to solve this integral? So like any 11 12 standard student can do it. Okay. Yeah, but cannot do completely, right? Uh, so, uh, so basically, first you have to replace x pi sin theta. Which one? Yeah, that is great. Yeah, but I won't follow this because of so the results would be like this: half pi to the power 8 by 5 times a beta integral. Sorry, so this is beta function. Okay, this is beta function bxy. Okay, I hope you know some of some of real analysis, right? Okay, so 1 by 2 pi, this minus pi to pi. So x you can take pi t first. Then you will have dx equals to pi dt, and one pi will come outside, and again pi square minus pi square t square for pi dt. And yeah, also one thing, this should be like when minus one, so okay, so minus one and two, sorry, one. And also one thing, okay, this pi will be cancel half uh, pi square, sorry, half, and pi to the power 8 by 5 will come outside, minus 1 to 1, so 1 minus t square 4 by 5 dt, right? And this is like even integral, right? Even function. This function is even. So f of minus t equals to f of t. Okay, because of t square is appearing. T square is appeared. Okay, and the half pi to the power 8 by 5, 2 times 0 to 1, 1 by t square 4 by 5 dt, and 2 to cancel, and then pi to the power 8 by 5 integration 0 to 1, 1 minus t square 4 by 5 dt. Now how to calculate this? Oh, so many is there. Okay, I cannot like write in next page since okay, so t equals to you can take basically t square equals to u. So right, t equals to root u. So you I am taking positive. Basically, t square is basically t lies between 0 to 1, so u is positive. So no problem. You can like do you can take the square root, and dt equals to your 1 by root u du, right? And So 1 by 2 root u. So half pi to the power 8 by 5 integration 0 to 1. So u to the power minus half, right? U to the power minus half because of this root u, and 1 minus u to the power 4 by 5 du. Okay, now how to calculate this? So I am writing here. So basically this is beta integral. Beta xy is what? Integration 0 to 1 x to the power sorry u to the power x minus 1, 1 minus u to the power 1 minus 1, so du. So yeah, and this is so for, yeah, this is another thing. So from here a half pi to the power 8 by 5 into, so u to the power half, so you can write like 0 to 1 u to the power 1 minus, sorry, half minus 1 because of minus half, and 1 minus u to the power what you can write 1 by 5 no, 9 by 5 minus 1, yeah, what you can write 9 by 5 minus 1, sorry, 9 by 5 minus 1. So this is half times beta half comma 9 by 5. So here p equals to half and q equals to, so p equals to half, q equals to 9 by 5. So then p plus q equals to what? So your half plus 9 by 5. So 10 5 plus 18, right? So 23 by 10. Okay, this is 23 by 10. Okay, so I have to make. Hey, is it clear, Ognibo? Okay, good. Okay, now one simple question is there. Question number 6, right? And just before like we solve this type of problem for all tau greater than 0. So here I'm considering real tau, no problem. Sorry, tau equals to tau to the power a, not tau to the power b. Okay, then the value of sin inverse ab is what? So already like we know. Okay, can you solve this, Gunivo? And just uh, let me know what is the solution. Please try. It is very easy, right? Did you get? Okay. This is simple, right? Very simple. So we know that this Jacobi theta is defined by and minus pi squared tau. Real tau is positive and 1. And yeah, and this is equivalent to. So do you know, right, how this satisfies? How this satisfies? You know, right? Nothing. Just you start with this, you will get easily. Okay. So in question is nothing but this. So basically, you compare with this. A is your minus half and B is your minus 1. You compare with this, which is given in question, tau to the power A and tau to the power B. So this is your minus half and this is minus 1. So AB equals to half. Okay. And sine inverse half is your pi by 6. Okay. Got it? Okay. Okay. Now, any question like you have, uh, your like you got stuck on any problem? If you have any problem, you can ask. Okay. Okay. Well, now any so one question about Richlet kernel. I think you know this is week one. Like we have week one content. You know the Richlet kernel, right? So this is dn theta is 1 by 2 pi sine plus half theta and theta by 2. Okay. So now question is so that minus pi to pi theta d theta is 1. So you are a master student? Oh, okay, okay. Okay. Um, so you know little bit answer analysis for method theory, right? Okay, good. So yeah, basically you know, right? You know the proof, like sine n plus half theta divided by sine theta by 2 is nothing but this series. This is a like trigonometric identity, nothing else. 2 cos n theta. Okay, now just put 1 by 2 pi, multiply 1 by 2 pi on both sides, and 0 to, so not 0, minus pi to pi sine n plus half theta sine theta by 2 d theta equals to 1 by 2 pi integration, not bracket, integration minus pi to pi 1 plus 2 sum k equals to 1 to n cos k theta d theta 1 by 2 pi. Yeah, so in left hand side you just 1 by 2 pi times this is nothing but your dn theta d theta 1 by 2 pi. So see, their cos is your even function and 1 is also even function. So 2 times 0 to pi 1 plus okay, equals to 1 to n your cos k theta d theta 1 by pi. So this is basically theta plus, and this is finite sum, so k equals to 1 to n. What is the integration sin k theta? This is sorry, cos k theta. This is sin k theta divided by k, and this 0 to pi. Okay, so for 0 to pi this will be vanished. Okay, for like by putting lower limit and upper limit. So 1 by pi times this theta pi minus 0. Okay, so this is 1. Got it, right? Okay. So one question is there in your assignment. So I'm not going to discuss that only. So the order of the growth, like of integration mod dnt dt, right? So mainly order means so upper bound and lower bound, so kind of thing. Okay. So some constant times, basically, equivalent type thing or approximate. So basically, the question is your 0 to pi mod dnt dt, something not constant. So yeah, constant times some function of f of n, because this integral is dependent on n, right? So not integral, the variable is t, but you will get a function of n, right? So that's why as intending to infinity also. Okay, now my question is that, okay, what is the lower bound of 0 to pi mod dnt dt? The limit of this, the modulus is like not finite, maybe. You can check it. Okay, so okay, let us start. Now 0 to pi mod dnt. So instead of t, you can write also theta. no problem, dt. So this is what 0 to pi. Just put sine n plus half t sine t by 2 dt. This is equals to, okay, one thing you can do. Okay, so to avoid this n plus half, so put t equals to 2x, 2 theta. T equals to 2 theta, then you will have the integral is 0 to pi by 2 and mod sine 2n plus 1 theta and sine theta, and also, yeah, to avoid this, okay, sine theta, and up will come dt equals to 2 so 2 d theta. Okay, now what you will do, so 2, okay, 2 times, so you can like you can now we want to find this integral. Okay, why did the researchers get interested into these bounds, by the way? So bounds about like DNT. Yeah, so see, DNT, basically, I think you have you have seen all the lectures video. So in lectures video, like whenever you like try to study the convergency of point-wise convergency or uniform convergency. So for this Fourier series, okay. So you will get this kind of Dirichlet kernel, okay. And so to show the convergency, you have to like you are like you will get this integral dnt, and yeah, absolute integrability, yeah. So in L1 to like if Hansen is L1 means like absolute integrable, right? So yeah, mod dnt, you have to like deal with this mod dnt, but this dnt is not convergence at all. Or what is the growth? Okay, so that's why upper bound, lower bound is coming. Okay, so growth means basically, see, so the definition is basically, so you have to find some constant, so C f of n less equals to dnt, sorry, integral 0 to pi mod dnt dt to C1 C2 Gn, right? So if Fn and Gn both are same, and in that case you will have this. Okay, got it little bit. Okay, so you see see all the videos. Okay, in there sir has like taught everything. Okay, and described everything why it is important. In lectures note is also there. Okay, so now we need this little interval, the small interval, 2n integration k pi by 2 to k plus 1 pi by 2 and this mod sin z by z dz. Okay, now this is like 2 times whole mod k equals to 0 to 2n integration 0 to pi by 2 sin z divided by, so see, just instead of whole interval, so we are taking one interval. Okay, that's why getter equals to this sin z by z and dz whole mod. And yeah, one thing, okay, no problem. This is getter equals to 2 times uh, okay, k equals to 0 to 2n, and so in last steps, so we have to do it. Okay, so this z, the upper bound is this. So 1 by z, the lower bound of 1 by z is this. Sorry, this. So you can write instead of z this, right? Okay, so this is equals to 4 times this sum k equals to 0 to 2n 1 by k plus 1. And what is the integration of sin z? This is minus cos z. Minus cos z 0 to pi by 2 is 1. Okay, so this is positive. Every term is positive. So 4 1 plus 1 by 2 plus 1 by 2n. Okay, and this is a kind of log n, right? Mm. So you know Euler constant, right? Okay, so the sum basically, so you know, if you know the Euler constant, so Euler constant is positive, right? Euler constant is positive, and so from there, okay, one thing here I made a mistake. This pi will be there, 4 pi, pi, pi. So log 2n plus 1. Okay, I get it equals to. So Euler constant is this sum minus this is Euler constant. So the Euler constant is positive, right? So you can write this, right? Then yeah. So this is the lower bound finally. Okay, so 0 to pi t t that equals to 4 by pi. So now you can guess what is the growth. So yeah, I'm not going to tell you because this is like assignment question. Okay, no problem. Now, if you have any like question to ask, you can ask me. Otherwise, I have to discuss another question because I listed these questions only. 8 questions. No, no, no. This is not surface bound. Many thing will like lose, right? Here only you can see. Uh, so this omega is basically 2 point something, right? So also not sharpest. Okay, you can improve this. But like we are dealing with main terms like log 12 plus 1 is important, not constant. Okay, the constant is not sharp, but yeah, this is sharp. This log 2n plus 1. As n tends to infinity, it is like sharp. It's sharp, sharpest bound. Got it? Yeah. So you are a PhD student then? Okay, okay. Okay, let me find two, three questions. Okay, one question also I have. Yeah, this question is also there. Question 8, right? Consider the function this cos theta sin theta equals to sin square theta, and u is your harmonic. Harmonic means you know, right? So del 2u del x2 plus del 2u del y2 equals to 0. Okay, or since this is a like theta related, like so you have another definition: x equals to r cos theta by putting x equals to r cos theta and r sin theta. So u r theta, like I think del 2u del r2 plus r square del 2u del theta 2 equals to 0. Okay, and harmonic, yeah, harmonic in the unit disk. Unit disk basically x square plus y square less equals to 1. Then the value of u00. So you enrolled this course for exam also, right? Oh, not yet. Okay. Okay. So, but if you like do carefully the assignments, then you will learn more. Okay. Okay. So this is like something related to your assignment problem. Okay. I think you know mean value theorem. So sir has discussed in week 2 content. Okay. Okay. So basically solution is by mean value theorem for the harmonic function for the harmonic function. And so here, sorry, no. First write the main theorem. 1 by 2 pi minus pi to pi. How it is coming? So you can check the lecture videos. Okay, very simple. This is equals to u 0, 0. For the like disk with radius r. Okay. Now for a unit disk here r equals to 1, right? So u 0, 0 is minus pi to pi u cos theta sin theta d theta, and this basically you have minus pi to pi, what u cos theta sin theta, sin square theta, right? Sin square theta d theta. uh, I missed this 2 pi also, right? 2 pi. And you know how to, so this is your even function, right? 1 by 2 pi into 2 into 0 to pi sin square theta d theta. Now 1 by pi, you know, this is 1 minus cos 2 theta d theta. And now you, sorry, you integrate this theta minus sin 2 theta by 2. uh, okay, 0 to 1, all why 1 0 to pi, right? So 1 by pi times pi, and then for this will be vanished. Okay, and this is 1. Okay, u 0, 0 is 1. Oh, one thing I made a mistake. Yeah, 1 by 2, because the 2 sin square theta equals to 1 minus cos 2 theta, and 2 2 2. The answer is half. Okay, is it clear? Okay, okay, no problem. Mm, okay. So please try to see all the lecture videos. Okay. Do you know Riemann-Leibniz lemma? Yes, do you know? Okay, forgot. Yeah, check. This is in week 1 videos. So actually this mod TNT will also come. Okay, in Riemann-Leibniz lemma. Okay, so That was different means. Oh, no, 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 no. Uh, Maybe you can you can study, but this is related to a Fourier transform. Okay, okay. So Riemann lemma, yeah, I'm like stating that. Okay, if F belongs to L1, L1 you know, right? LP you know. Then we have both the limit A to B cos nt F t equals to F t dt 0 and dt equals to. So combining them, this limit tending to infinity A to B ft times e to the power minus int dt is 0, right? So 1 by root pi, and instead of um, minus pi to pi. Okay, and this is your nothing but a Fourier transform. So on the interval, of course, minus pi to pi, a Fourier transform of of f. So limit n tending to infinity. Okay, maybe this is not pi. This is root 2 pi. Okay, so f at t, not t. Okay, pi. Yeah, minus nt. My nt. This is 0. Okay. So that's why Riemann-Leibniz lemma is important. Okay. I think. Okay. Let me check once whether I'm correct or not. I hope. So, Riemann-Leibniz lemma. Oh, yeah, yeah, yeah. F at n, not t. So why should be t? So t is your integration, right? Sorry, n. This is 0. Okay. Got it? At least little bit. Okay. Thank you. Okay. So today up to this I prepared. Okay. And if you have some questions to ask, something looser than L1. No, 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 no. Uh, must be should be in L1. Okay. So there is like counter example. So yeah, at least you need L1 space. Should be integrable, absolute integrable. Yeah, you can construct for L2 function also. Uh, yeah, yeah. But see, any like continuous function, for any continuous function you will have this, because your continuous, all the continuous function is integrable. Okay. Yeah, or at least in this interval. Okay, so I am not talking on R. Okay, I am talking on this interval minus pi to pi. Yeah, only finite interval. Pi to pi means basically f should be periodic. Will help somewhere in future to know. Yeah, yeah, yeah. Of course. Yeah, this is very important. Riemann-Leibniz lemma. Okay. If you like want to do research in analysis, basically like harmonic analysis, your operator theory, also in number theory, analytic number theory. So frequently you will use this. Okay, somewhere where like you will use Fourier transform. So maybe it is required. Okay, sometimes. So you are interested to pursue PhD? Oh, okay, okay, okay. Yeah, actually, this also it is require. This course is useful for engineering student also. Okay, because they also use this Fourier transform frequently, right? Okay, no problem. So now, if we have if you have no problem, no question to ask, so now we can conclude this session here. And from yeah, next day, please join on the same time. Okay, thank you. Okay. Yeah, okay. Thanks. Okay.